Okay, so again, I'm not going to do every step, but I do want to point out initially what you should be doing a problem like this is trying to reduce the degree of that by factoring out a common factor between all those terms over there. And it appears to be 3x. Now, once you do that, the problem becomes a little bit simpler to analyze. And what do you get over there? You would get, 3x cubed. Excuse me one second. And then you'd get, let's see, you'd get minus 8x squared. And then you would get 16x. And then you would get minus 8. The advantage of doing this is it really kind of reduces the choices on the potential roots to this. So if you're looking at the roots of this thing, it's cubic in x, the rational roots, and these are candidates. I'm not going to say you would try them all, would be plus or minus, the factors of 8, 1, 2, 4, and 8 over the factors of 3 are just 1 and 3. So I realize that that's complicated. I don't mind people using a calculator, but one wouldn't work, all right? And 2 doesn't work, and 4 doesn't work, and 8 doesn't work. I would hate to see someone check all those. It's probably fractional, all right? What I mean by that, it could be, looking at it like 1/3. And again, if you have a calculator, you could check it. I'm not saying you can't, but I think you'd eventually stumble on a root to be 2/3. What do I mean by that? When you plug in 2/3 here, x equals 2/3, this would give you 0, right? Now, if that's true, that means 3x equals 2, or 3x minus 2 is equal to 0. And then you know what we do? We do a long division, all right? Now, again, I'm not going to go through all those details. For one thing, it takes a lot of room, a lot of paper. And yeah, I went through it. Let me erase this over here. And I'm going to say that then I would get 3x, and then what would you get over here? 3x minus 2. And once you do that, over here, this would be quadratic. Right, I'm going to say if you do the long division, you get that, all right? So what are you going to get? You certainly get the 3x. You get the 3x minus 2. And yeah, I did the long division, and I got x squared minus 2x plus 4 for the quadratic, all right? Now, someone says, are you going to do the same thing with the other one? Not really. But what I'm going to do with the other one, let me erase this first. This is done. We're done with that. The other one, looking at it, I'm definitely going to pull the 5 out. And the reason why, it just makes it so much easier for me to look at. So what'd you get? 5. And then what'd you get? Well, let's see. You get 3x 4 minus 5x squared plus, cubed, plus 5x squared, that's a cube, minus 11x plus 6. Now again, I have an assumption to make, and it might be a assumption that you're saying, is it really true? I don't know, but I would make an assumption that it's got something in common with the first guy, something in common with the first guy. And I'm going to say the linear factor, so 3x minus 2. And then what are you going to do? Long division again. And when you do the long division, what you're going to get here is a cubic. You're going to get a cubic there. But when you do the long division, you're expecting a long division with a remainder of 0. All right? So I'm going to claim I'm not going to do the long division for you. It's kind of pointless because we've been doing it for a while now. But you're going to get the factor 5, 3x minus 2. Yep, I did the long division, got remainder 0. And that's the remaining quadratic, or the quotient there. All right? Now, granted, someone says, well, could you factor those guys? You could try, but I'll be honest with you, the quadratic in the first one, nothing you're going to do is going to get that working finger numbers. And the second one, I wouldn't even bother at that point. I really wouldn't. But it's also, it doesn't appear to be factorable. So what's common between those two? 3x minus 2. Thank you.